guys, welcome back to my channel. Today we'll finish equilibrium. First, starting with the homework from the last video. The first question, water going into steam, and the temperature was 110 degrees Celsius, and we had to decide the factors. So the answer is C. Why? Because we know that water is going from liquid to gas, so the entropy is going to be greater than 0. It's going to be a positive number, so we know delta S is greater than 0. Then, if the entropy is high, and we know that water going into gas is a natural process, so it is spontaneous, so we can say that delta G less than 0, right? So it's an exergonic process. We can say that the reaction is most likely to be exothermic. Why? Due to the reaction delta G is equal to delta H minus T delta S. Entropy is positive and enthalpy is negative. It's more likely to be exergonic. The second question was, which one of the following has a greater entropy? We had copper sulfate in solution, and we had copper sulfate as a solid. Now we know that solids are tightly packed, and a solution is more loosely packed, right? So if I add the copper sulfate into a solvent and we have the solution, there's going to be more disorder than there would be if it was on its own. The third question, you were given a reaction of water going from liquid into the solid phase, so basically freezing. And you were given the enthalpy as 46 kilojoules per mole, and we know this was positive, so we have an endothermic reaction. Now you have to say whether it is spontaneous or not. Keeping our favorite equation in mind, we know that delta G is equal to delta H minus TdS. Now, we know that liquid to solid is entropy falling, so delta S less than 0. So if we have a positive delta H and we have a negative delta S, so negative cancels out to give us a positive number. So positive delta H, positive delta S, we're going to get a positive, gives free energy, which means that it is endergonic and the reaction is not spontaneous. Okay, starting with today's lesson, equilibrium. You need to know that if you add something to a system, the system will try to counteract the change. So if I increase something, the reaction will try to move to a side or do something to decrease it or to bring it back to normal. So we're going to speak about concentration first, then pressure, then volume, then temperature, and finally about catalysts. Okay, starting with concentration, we have a reaction. A plus B will give us C plus D. But before I continue with concentration, I want to tell you two things. So the main question about equilibrium is what will happen to the reaction, in which direction. Direction is the main word. In which direction will the reaction proceed in order to counteract the change? So the first option is that it will shift to the right. The right is the product, so we can either say shifts to the right, we can also say it favors the products, or we can even say that it goes to in the forward direction. And obviously the second option is going to be shift to the left, or it goes towards the backward direction, or it favors the reactants. This is the main question about equilibrium. Now continuing with our concentration. So if I increase the concentration of the reactants, the reaction will try to increase the concentration of the products to counteract the change. So in this, if I do that, the reaction will go to the forward direction to use up these reactants that have been increased and to form more products. If I decrease the reactants, the reaction will favor the reactants. Why? So that the reduced reactants can be increased and the system can become normal again. Okay, let's do a question together. So let's say I increase the concentration of C in this reaction. So what is the answer going to be? What is the direction of the equilibrium? It will move to the left. So there's a shift to the left, it favors the reactants so as to decrease the increased concentration of C. I hope it is clear. So now I'll move on to our second one, which was pressure. Now pressure is only for gases, okay? A reaction that has gases, pressure can be applied there. Alright, so if I increase the pressure, the reaction will move to the side with the fewer molecules of gas. And if I decrease the pressure, the reaction will move to the side with the higher molecules of gas. So let's have the same reaction that we had, A plus B and C plus D. We're going to have some numbers so that we have different number of molecules on each side. So 3 moles on the reactant side and 2 moles on the product side. Now, because there are only 2 moles of gas on the right side of the reaction, then if I increase the pressure, there will be a shift to the right, to the side of the fewer molecules. Now, let's do another question together. So we have hydrogen gas and iodine gas giving us hydrogen iodide. Now we have 2 moles on the reactant side and 2 on the product side. So if I increase the pressure, what is going to happen? The answer is nothing. So there is an equal amount of work on both sides of the reaction because the number of moles cancel each other out. There is no effect on the direction of the equilibrium. Now we'll move on to volume. Volume also acts only on gases. So volume and pressure are terms used for gases. So we have the same reaction again, A plus B, C and D, and we also have numbers involved. So we have 3 moles on one side and 2 moles on the other. Now, increasing the volume will move to the side with the higher number of molecules. It's the opposite to pressure, and decreasing the volume will move to the side with the fewer molecules of gas. Please remember that volume and pressure are reciprocal. Okay, so we have an equal reaction here. We have ammonia, which is a gas, and oxygen, which is also a gas, and from here we get nitric acid and water. Now let's try to find the number of moles. The number of moles is 3 on the reaction side and 0 on the product side because there are no gases. So the question is, what will happen if you reduce the volume? So reducing the volume has to go to the side with the fewer molecules. So there is a shift to the right because there are 0 moles of gas on the right side. So it favors the products. Okay, now moving on to our fourth parameter, temperature. Now temperature, it depends on whether the reaction is exothermic or endothermic. Endo is positive, exo is negative. Endo is the gain in heat energy, exo is the loss of heat energy. Now increasing the temperature will move the reaction to the side where it is endothermic, and reducing the temperature will move to the side where it is exothermic. Why? So if I increase the temperature, I want the system to absorb this heat energy, right? So it will go to the endothermic side. And if I decrease the temperature, I want it to go to the side where it's releasing heat energy, where it's getting more heat. So we have an example here. Again, our favorites A and B and C and there's no D here, so we just have A and B and C plus heat. Now plus heat means it is releasing heat energy, so delta H is negative. Now what will happen if I increase the temperature? Okay, we know that the forward reaction is exothermic, so this makes the backward reaction the opposite. So the backward reaction is endothermic, and increasing the temperature goes to the side of the endothermic reaction, so there is a shift to the left. It favors the reactants. Okay, coming on to our last parameter, catalysts. Well, catalysts, they only increase the rate of the reactions and equally, whether it is the forward or the backward reaction, they increase the rate equally and they have no effect on the equilibrium, on the direction of the equilibrium. This is important for you to know. Alright, our homework for today, I will give you 3 reactions and I will give you some changes in parameters, and you have to tell me the direction which the equilibrium will shift. Okay, the first question is carbon dioxide. Look at the state of the compound, so gas, and you have carbon fluoride. So what will happen if you decrease the volume in this reaction? In the second question, what will happen if you increase the temperature? It is an endothermic reaction. And the last one, you have to tell me in which direction will the equilibrium shift if we add a catalyst. If we add a heterogeneous catalyst. And that would be it for this video. Hope you understood everything well. I'll see you in my next one. Until then, take care. Bye.